Okay, so I wanted to talk a little bit about data splitting and cross-validation in this video. So Weka does a lot of things behind the scenes, and it has limited options for outputting those kind of what's going on behind the scenes. And I wanted to show you cross-validation in a little bit more depth, but unfortunately I couldn't get Weka to output everything I wanted it to. So this is going to be a video in Python, and so you won't be tested on this. Don't worry about knowing Python. I'll explain everything you need to know about this. But I would really like to show you what's going on behind the scenes with cross-validation, and really the best way to show you that is to use a programming language. Okay, so we're working the same data set here, and this is a script I wrote a while back for that data set. So on the top here I just have a bunch of imports. Basically these are different libraries, these are different learners, and then I've written a function that does some pre-processing on the data. So remember before in Excel we would drop some columns and drop some other things, and so that's all this line of code does. We filled in values that were missing, NA values, not available values, and in this case I'm just going to fill in the median, which is fine. In Weka you can just put in a question mark and it tries to figure out the best way, but with this machine learning library, with this data mining library, we kind of have to pick a method, and that's kind of nice having that control. Sometimes you may want to use the median, sometimes you want to use the mean, sometimes you want to do something more complex, and there's a lot of other complex ways. I don't want to get into it, but that's all I'm doing up here. Really the meat of what you need to know is from this point right here down. And so I've created some functions. So all this is doing is I'm reading in that training data that and then I do some pre-processing. And then right here I'm kind of separating it. So this is kind of notation you see from statistics. All of our independent variables, everything but our classification, whether they survived or died, that's kind of contained in the capital X. That's our independent variables. That's our predictor variables. There's a lot of different names for it. And our Y is going to be, that's going to be our classification, whether they survived or not. That's going to be our dependent variable. That's going to be our response variables. There's a lot of different names for these sorts of things. So that's all I'm doing there. So later down here in the code, if you see a capital X, that's everything but our classifier, and the lowercase y is our classifier, our classifier column, I should say. So you can see these next few lines of code. When you see this little hash symbol in front of it and it's kind of blue, that's what's known as a comment inside of Python. It just and I think everyone here has taken COP 2000, so you should have an idea of what a comment is. I'm just basically right now I'm using random forest, but I can uncomment these and use some other ones. Gaussian naive Bayes is a pretty popular one. That's what the NB stands for, so it's Gaussian naive Bayes. We're going to do ensemble learning later in the class, so that's what this boosting is for. This SVC one here, that's actually a type of support vector machine. So we've got a lot of different options available. Weka is older and it has more features, but when we do things in a programming language like Python or something like that, we have a lot more control. So I've noticed a lot of people moving away from kind of the types of programs where you're kind of just clicking around and setting some options to programs that you may have a little bit more control. So R is getting very popular, Python is getting very popular. A lot of the different data tools where you kind of use them as command line and pipe them together. So it's a good thing to know, even if you're not super into programming. And I should say, anybody who wants to do a little bit of programming, there's definitely always opportunities for extra credit. Just let me know what you want to do. It doesn't even have to be in Python. If you want to experiment some other way, doing some machine learning or data mining, just using a programming language, that's really what this course is about. I really want you to have some working knowledge. This is not really a theory course. This is how to actually do some data mining. So there are always extra credit opportunities available for anybody who has the time and wants to do it, and just kind of wants to learn some things and get some free feedback that you might not be able to get otherwise. Okay, so this next line is what's actually important. So we've spoken a little bit about cross-validation. Essentially, what cross-validation does is it makes the most efficient use of testing your data. So I've got some training data set, and I want to kind of score my estimator, my classifier, my machine learning model, and I want to know how well it's doing. Well, one of the ways to do that is what's known as a split. You can do an 80-20 split, you can do a 90-10 split. and basically you say, okay, I have some data and I'm gonna train my models on 80% of it, and then on 20% I'm actually gonna test it, which is fine and it works okay. But what they've been able to show, and there's mathematical proofs of this, and statisticians have worked a long time on this, and that's why you kind of see cross-validation so much, is that you can make way more efficient use of that data if you what's known as resample. So instead of doing a single 90-10 split, what if you took your data and said, I'm going to do a 90-10 split, I'm going to have 90% as training, I'm going to have 10% as test, I'm going to store that statistic, and then I'm going to move on. I'm going to say, okay, I'm going to have a different 90% and a different 10%, and it's kind of a sliding window. That 10% is just you tend to want to use a new 10% each time, and then I'm going to store that. So Weka just kind of gives you the final answer. So when you do cross-validation, you're doing 90-10 splits 10 different times, and you actually get 10 different sets of metrics. You get 10 different accuracies. You get 10 different area under ROC curves. You get 10 different true positive rates and false positive rates. Weka hides all that. Weka just shows you the final result, and the final result tends to be the average. But with this programming library right here, I'm going to show you all the individual scores, and then I'm going to show you kind of one technique is to take the mean, just to average them all together. So I'll go ahead and let me run this. So I just called it example.py. Okay, so I know this is a little difficult to read. The output's not always the greatest, but so here's all our individual scores, and these we should have 10 different scores. And this is you can see here. Right now I'm just saying I want the scoring to be accuracy, and so let me explain this a little bit. So here I'm saying use this estimator, and the estimator is going to be random forest. This is our independent variables. This is our dependent variables. I'm doing CV equals 10, so that's 10-fold cross-validation. And the scoring mechanism I want to use is accuracy. So in Weka, we would typically just get this. We would get the average score, the output. And this is a little high. This is misleadingly high, is because I've worked on this data some, and I've done some processing on it. And it's actually overfit a little bit, because if you actually run the test validation set on it, it scores really low. It scores, I think, in the 60s or 70s or something. It doesn't score that great. So this is an example of a model that's overfit. I think I've done too much to the data, and it works really well in the training data set, but it doesn't really work that well in the final data set. But so that's why you see these numbers so high. There's nothing magical about Python. I think the data is overfit, and we talked about that in previous videos, and why overfitting can kind of give you misleadingly high numbers, and then you think your model is great, and then you go to use it in practice, and it's terrible because you've kind of overfit. So that's why our score is so high. But if we were to do the same thing in Weka, we would just have the final score output of the average. And so these are our individual scores, and we have 10 individual scores, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then all Weka is going to do is take those individual scores and output them. So that's what you kind of see in Weka, and I wanted you to understand a little bit of what's going on in the background, and that final score that it output, that's all it's doing, is they're taking these 10 individual scores and averaging them. And I was really looking for a way in Weka, and maybe somebody can find it, and I'll definitely give you some extra credit for that, of actually outputting the individual models of the cross-validation before averaging. So here we're using accuracy. I think if we gave it a bad scoring metric, that it'll tell us our options. So let's give it a bad scoring metric, and let's see if it tells us our options. Okay, so I don't know how well you can see that here. We have accuracy, average, precision. So we have a lot of options. We have our F1 score. Let's do precision, because we've talked about that one. So let's change this to precision, so we can have it. And let me clear the screen here so it's a little bit more readable. So these are our precision scores, and we have a very high score for our precision. It's really high, and then we get some output, our average score. And you can kind of see there's something going on with this first split, so it might be worth investigating what's going on here, because whatever this first split is, it's really low, but it enables all the others to seem really high. So when we do our average, our average turns out to be a lot higher than it should be. Another score was, I saw F1. We had our F1 score, which is just another statistic. I haven't really explained what that one is, but we can show it at least. So this is our F1 score. So that's all Weka is doing. But one thing to note, when Weka gives you the final output of the model, so say your decision tree or our linear regression, that's done on the full data set. That has absolutely nothing to do with cross-validation. That final model that it spits out is based on the full data set. The only thing cross-validation is just for getting performance metrics. That's the only thing that it's for. So if you were to build a model based on some parameters in Weka, and then without any sort of cross-validation or anything, you just built a model, and then you built that same model with cross-validation options on, you're going to get that exact same model. You're not going to get a different model. The only thing that cross-validation has done is it's given you a different way to test that model. You're going to get performance metrics that are more useful, and they're kind of considered more well-rounded. They're better, but they aren't. The model it produces isn't any different. So I really want you to understand the difference between that. And you can experiment, definitely experiment, and you can see this is true. You can play with the cross-validation options all you want. It's going to spit out the exact same model every single time. The statistics on the scores may change because that's what the cross-validation actually does, is it figures out how good the model is, but the final model that it spits out, those statistics are kind of for you. It doesn't help and it doesn't assist in building the model. Weka doesn't know how to build the model any better. They're really for you, and you can say, okay, I built some model. It's pretty good. Let me see if I can make this better. So hopefully I didn't confuse anyone too much by showing you the Python code. Again, standing offer for extra credit for anyone who wants to do a little bit of coding in Python or really any other language, and I can show you some popular libraries. R would be another good choice if you wanted to do something in R. R is extremely popular. It's I would venture to say it's even more popular than Python, and Python itself is pretty popular. So by doing that extra credit, you're really helping yourself kind of learn some of these things that are used in practice. But if not, if you're not a coder, if you already have a full set of classes and you don't want to do anything else, you just kind of want to get through this course, that's fine too. I completely understand that. But for anybody who wants to learn more and kind of get some alternative ways of doing machine learning under their belt, that's definitely something that still stands.